Hello friends, welcome to my channel. Let's have a look at problem 1137, nth Tribonacci number. In this video, we're going to present two formats of dynamic programming solution. So typically, when we learn or when one learns dynamic programming, so one typical or classic problem is the Fibonacci number, right? So here, different from that, it's a small step right further, the Tribonacci sequence. So here, this sequence Tn is defined as follows. So here is a recursive formula. So we have T0 equals 0, T1 equals 1, and T2 equals 1. And then the last one will be the sum of the previous three numbers. So given n returns the value of Tn. So here is the result for n equals 4. So similarly for n equals 25. So this is the number accumulated. So before we do the analysis, let's also look at the constraints. First, here in this problem, the n is bounded above by 37, so which is actually a not very large number. However, the result is very large due to the accumulation. Secondly, the answer is guaranteed to fit within a 32-bit integer, right? So with that said, let's look at the problem solving. So here, this problem is actually very routine. So the method or the technique we're going to use is dynamic programming. So first, let me write a very robust dynamic programming solution, and then we simplify the space usage a little bit. So first, let's treat the case when n is less than 2. So in other words, so when n is 1, 0, right? So we are going to return n, right? So then we can consider the case, right? So even actually when n equals 2, we should return 1. So now let's consider the case. Let's also do this. If n equals 2, right, we just return 1. This is also, we are treating the first three. And so once we have this first three, so we can iterate. So here, let me use a DP table. So first, I'm going to use this times n plus 1, right? So dpn will correspond to the Tribonacci number for n, right? Then we have dp0 is not 0, and dp1 is 1, and dp2 is also 1, right? So once we have this, then actually we can do the iteration. So this is a for loop for I in range 3 over up to n. So we write n plus 1 here because n plus 1 is not included. So what we are going to do is that we set dpi to be the dp I minus 1 plus dp I minus 2 plus dp I minus 3. So notice the index. So because here we are starting from index 3, so this index I minus 3, smallest one among these three, is still greater than or equal to 0, right? So once we finish this set, so we just need to return dpn, or dpn minus 1 in this case, if you like, the last element. So this is the one solution format for this problem. So we can do a test. Yeah, it passes all the cases up to 37. Yeah, actually we can test 37. So what's the number, right? So 37. Yeah, this is actually not a small number, it's large, right? So this is the one version. Let me copy this function signature and copy this part, and then let me change this one to be v1. So we want to improve the space complexity a little bit. So here we are using essentially Ln of space, right? So here, let's see, I'm going to do this. Let's ignore this part. So then we can, once we have this n equals 1, 2, so we can iterate for n larger, right? So we can initialize as this one. You can imagine it's corresponding to 0, 1, and 2, right? And then what we're going to do is iterate this number of times. That is n plus 1 minus 3, right? So for I, so let's use a dummy index in range. So we're going to 3 n plus 1. Actually, it's make a parallel with this first version. So actually, if you like, so you can just use n minus 2, range n minus 2. Just the number of iterations is essential here, not the specific index range, because we are using a dummy one. So right, so in order to make this, first let's introduce some temporary variable, b temp and c temp. So before b and c change states, and then we are going to set c to be a plus b plus c, right? The previous 3 one, and then we set b equals c temp and a equals b temp, right? So afterwards, the c will be the state of the Tribonacci number. So we're going to return c. So this is the second version of this solution. Let me do a test. Yeah, it passes the last one. So now let's look at generic case. Yeah, it passes all the cases. So as we mentioned at the very beginning, so the Fibonacci number problem is a very classic dynamic programming practice problem. So this actually is just a step further. So it involves 3 numbers in the second version. So with that said, I guess that's about it for this problem. So you are welcome to check out my channel for dynamic programming problems and many more algorithms and the classes of problems from Leetcode and other resources. With that said, that's it. Thank you.